Leetcode 63, Unique Paths 2. Cells can be blocked. You still move only right or down, but you may not enter a one cell. Example 1, 3 by 3 with the center blocked. There are exactly two paths from start to finish. Example 2, 2 rows, 2 columns, with the top right cell blocked. Only one valid path, down, then right. The recurrence is the same as unique paths without obstacles, with one guard. If a cell is blocked, the robot cannot step on it. So that coordinate has 0 ways to reach it. Any path count that tries to pass through it dies there. Classic trap: on the very first row or column, you cannot hop over a block. If an obstacle sits in that line, every cell to its right, or below it on the first column, is unreachable. Counts drop to 0 and stay 0 for the rest of that strip. The DP formula is unchanged: current cell is left neighbor plus above neighbor. A blocked above neighbor is simply 0. If the wall has no history to give, you only inherit from the left. When obstacles form a complete barrier, positive counts never make it past. Zeros propagate through the gap until the bottom right reads 0. That is the answer: no valid path. Initializing the first row is now critical. Sweep left to right, each free cell gets one way so far, until you hit an obstacle. After that wall, nothing to the right is reachable on this row, so those entries stay 0. Treat the finished first row as history and tint it green. Open a fresh blue present row under it. Along the first column, if the cell is free, present copies history, here that copies a 1 into the corner. At column 1 the cell is free. Pull the count from history above, add the left neighbor in present, 1 plus 1 gives 2 distinct ways. Column 2 is an obstacle in the grid. No matter what history or the left neighbor say, you cannot stand here, so we do not add, we hard set this entry to 0 and highlight the block. At the last column, history and left both feed 0. 0 plus 0 stays 0. The bottom right never receives a positive count, so the number of valid paths is 0. Second walkthrough, same mechanics as before. The input is obstacle grid, 3 by 3, zeros for free cells and a 1 in the center, so the middle square is blocked. Moves are still only right and down, and you may not step on a blocked cell. Initialize the first row. There is no wall on row 0, so from the start you can walk right across free cells. Each cell picks up exactly one way from the left until the whole top reads 1, 1, 1. Now the same two-row picture as before, the finished row becomes history in green, and we open a blue present row underneath. Along the first column, if the cell is free, present copies history, so the corner again gets a 1. Move the band to the middle column. The grid blocks this present cell, so we do not add neighbors. We pin the count to 0 and emphasize the granite square, just like the earlier hard guard. Slide the band to the last column. Pull from history above, add the left neighbor in present. 1 from above plus 0 from the left leaves 1, write it in the ghost row 2. Roll forward, present becomes the new history, 1, 0, 1. The middle present square is free on this row, so we restore it to a normal blue cell. Copy the first column, then add above and left for the interior. The bottom right becomes 2 distinct paths that bend around the blocked center. That is the answer for this grid. M is the number of rows and N is the number of columns. Time is O of M times N, each cell is processed once, and each update checks for an obstacle and combines the cell above and to the left in constant time. Space is O of N when you keep a single rolling row. Materializing the whole DP grid uses O of M times N extra space. Pseudocode for unique paths with obstacles using one rolling row. We bail out if the start or goal is blocked, initialize the first row with the shadow rule, then sweep each remaining row while forcing obstacles to 0. M and N bound the DP grid. If start or goal is blocked, answer is 0. Return immediately. One array of length n holds the current DP row. Top left starts at one way when it is free. Walk the first grid row after the corner, left to right. First obstacle on row 0 zeros this cell. A blocked top cell contributes no paths here. Else branch when this top cell is free. Copy the running count from the immediate left. Each outer iteration refreshes the next grid row. If this row blocks column 0, clear the edge count. Write 0 into row at index 0. Walk interior columns for this row. If this grid cell is a wall, the count is 0. Overwrite this interior slot with 0. Branch for a free interior cell. Add the value from above plus the left neighbor already updated in this sweep. Return the last entry, valid paths to the bottom right corner.